All right, guys, I'm going to try to do, some of the examples in the textbook so that you could, if you've printed off the PowerPoint, which personally, if you have a printer, I would strongly suggest that you print off the PowerPoint. I always print it to where it has 3 slides on one page so you can kind of do these examples over to the side, but really it's really good for you to be able to highlight and to write these examples. So if you could do that, but if not, just do these examples on another sheet of paper, that would be helpful. All right, so example 9.1 says, what's the symbol and charge for a calcium ion? So if you look at the calcium ion, so crud, I wish I had here we go. If you have your periodic table in front of you, calcium is right here, okay? And what group is it in? What column is it in? It's in column 2, right? Okay, so how do you write an ion? All right, so let's see. Just did this one right here. All right, so what you do is you write the symbol, and then if it's a metal, it's a plus. If it's a non-metal, it's a negative, and then you look at what group it's in for the metal. So since it's in group 2, it's 2 plus. And that's it. Example 9.2 says, what's the symbol and charge for aluminum? And it gives you the answer. But again, if you look over on the periodic table, I'll go back to it really quick. Aluminum is over here. So you might think, well, wait, that's way over there. How is that 3 and not this one 3? Well, because you're just doing the representative family, which is basically those tall ones. You leave this section out of it for now. So aluminum, again, is a metal. And so that means it gets a plus, and it's in group 3A. So it becomes 3 plus. Okay? So that's this first couple of examples. So let's see, is that it for chemical bonds? Surely not. Oh, there were some things that I wanted to point out to you that the PowerPoint just didn't give. It might have given table 9.1, but I want to look here a little bit at, these are important tables, 9.2 and 9.3. Okay, so look and see how there's this variable charge ions. So things like that are in the middle of the periodic table. So let me go back to the periodic table really quick. I said that we would get to it, didn't I? All right, so like for instance, chromium. See how it's kind of in this middle section? So that means that those are called transition metals, and that means that they can have different charges. And so whenever you deal with elements that are in that section, you need to look at this table, 9.2, to be able to determine what charge it has and basically what it's going to transfer over to the other element whenever it does that crossover technique. So we'll do some examples of that just so you kind of understand what I'm saying here in a minute. But then also on table 9.3, these are what are called polyatomic ions. So these are pretty important as well. The reason that they're called polyatomic, so if you've ever done medical terminology, then poly means many. So you can see that these have many elements, or at least 2 or more. And so what happens is, see how they have these charges on the back of them? What happens is, because they have those charges, most of them are all negative except for ammonium. It's the only positive one on there. But all of those have charges, and so they act like ionic bonds. So like for an example, let's see, let me give you an example really quick. This is not example 9.3. Let's say I have sodium, which is a positive ion, and I have acetate floating around. Okay, that's that very first one. See how this one is positive and this one's negative? So what happens is they attract and they end up making this really big compound. Okay, so you'll have to do this in the lab that you will have next week, where you'll have to look at these polyatomic ions a lot. So let me give you another one. Let's do lithium, and let's do chromate. So chromate is this one. The reason I wanted to do this one is because they have different numbers. So they have +1 and -2. So what happens is you take this 2 and you pull it down over here, and you take this 1 and you pull it over here. So you end up with Li2CrO4. And you don't have to write a 1 after it, okay? So we'll do some more of those actually towards the end of the chapter. I just wanted to kind of show you what's going on with these polyatomic ions. All right, so example 9.3. Example 9.3. This says to use the electron dot notation to predict the formula of a compound formed when aluminum combines with fluorine. All right, so electron dot notation. So if you were going to do the electron dot notation for aluminum, you look at the periodic table. So everyone look at the periodic table. Aluminum is in what group? Well, it's in group 3A. So that means it has 3 dots. Okay? Now fluorine, if you look at it, is in group 7A. So it has 7 dots. So what happens is you know that since aluminum is a metal, it's going to want to lose electrons, and since fluorine's a non-metal, it wants to gain electrons. Well, if I get rid of that 1 outer electron, then I still have these 2. So I got to get rid of those 2, which just means that I got to have more fluorines. I'm just so sad that we're not in class, because everyone usually always gets into this stuff. I know you're probably not getting into it very much right now because you're having to do it at home and listen to me over a recording, but hopefully this is kind of making some sense. All right, so then example 9.4, you have to predict the formula again by doing electron dot notation for aluminum and oxygen. Okay, so again, aluminum is 3 outer electrons. Oxygen, if you look at it, has 6 outer electrons. So this one's kind of funky because it needs 2, but then there's like 1 extra. So that's weird. So you're gonna have to have another oxygen, but you only have 1 electron. So what do? You have to add another aluminum too. So then that one goes there, and then you add another oxygen, and then those 2 go there. So then you end up with Al2O3. You had 2 aluminums, 3 oxygens. Let me just show you something really quick using that crossover technique that we talked about in one of those videos. What's the ion for aluminum? It's 3+. What's the ion for oxygen? Okay, let me go back to my periodic table for this one because I want to explain this one more time. Oxygen's right here. It's a nonmetal. So basically you start from this side and go backwards. Noble gases are 0. This next one is -1. This next one is -2. This next one is -3, and so on. So oxygen here, this was -1, this was -2. Oxygen is -2. So you write it like this actually. And then you take this 3 and you pull it down here, and you take this 2 and you pull it down here, so you end up with Al2O3, which is exactly what you have whenever you do the electron dot notation. So it's just kind of a way to check your work. All right. Let's see. I'm trying to think if I have any more. I don't.